Okay, now we're up to graphing revenue and expense functions. If you haven't done that little activity on graphing just a revenue function, you really need to do that first so that this makes sense. So again, I won't read through everything on the notes here. I'm just going to kind of fast forward. It goes back through some algebra ideas about what a parabola is, how you find axis symmetry and maximum, just some basic ideas. I really want to go over a couple examples here. They're all kind of chained together. It just kind of breaks it up into pieces for you for how you do the whole process. So it starts off talking about this company called Picasso Paints, and it cost them $7 to manufacture their paint, and it cost them $28,000 in fixed cost. So ultimately we're getting an expense equation. Before we do anything else, we really need to create an expense equation here. So for expenses, we know that that is equal to your variable plus your fixed expenses. And for this company, their variable cost was $7. It said it cost $7 each to make their paint. You can put the decimals there and that's fine. It's just $7, so you can just put 7 if you like. It's $7 for each paint they make. So the more paint they make, the more it costs them to buy the materials. So $7 times the quantity they make, or Q. So 7Q plus their fixed cost, which again was $28,000. This is the first section where you got to really be careful with terminology. This is expense in terms of quantity. We're going to take it to another level. Now, this is kind of the third level of everything, and this is the final level that we're going to get to with our graphs. But so far, we've done supply and demand, where it was price and quantity here. And with this type of equation, we've looked at your expense dollars. I'm going to put that in parentheses. Not price, but dollars you're spending, your expenses, in terms of quantity down here. Okay. So that's, again, tied to supply and demand. The quantity that was on your y-axis in supply and demand is now the x-axis in this. So you can take supply and demand, plug that into expense, and move on from there. So that's kind of where it all ties together. And that's where this is going. They give us a demand equation also. It says it's negative 500p plus 30,000. We can do substitution here. If that's what Q equals, if that's what quantity is, that equation can be plugged in for Q right there. And that's what this work is going to do. Before that all happens, I want to point out something to you. Once we plug in this demand equation, and I'm just going to do it this way because the book's already got it explained. Once you plug this in for Q, you're going to have expense with some other stuff in terms of price plus some other stuff. But that's the key. It's something in terms of price. So now when you go to graph, this is still expense dollars, not price, expense dollars. That's where it's kind of weird. Down here is your price. So it's dollars per dollar. It's kind of a weird way to think about it. But as your price per item increases, how does your overall expenses react to that? That's how the graphs are going to look. You're going to have to pay attention to your axes. You're going to have to pay attention to what variables you're using. Okay? If that's a Q right there, the graph has to have a Q. If that's a P, the graph has to have a price. You've got to pay attention to that stuff or you're going to mix all these graphs up. So let's look at what they're doing here. They're taking the expense equation in terms of quantity. And we created that from the information they gave us. But we want to take the quantity out, replace it with the demand curve, which is in terms of quantity, or defined for quantity. So you plug all that in for Q. That's what they're doing. They're substituting. Okay? You did substitution in Algebra 1 and Algebra 2. You're using it again here. All right, now that they've plugged that in, next step is to distribute the $7. And it says right here, use distributive properties, so that's what they're doing. They're distributing. Okay. And then finally, you just combine your like terms. There's a lot of Algebra 2 going on here. Okay, so you got to understand Algebra. That's why you had to have Algebra 2 before you took this class. There's a lot of Algebra 2 going on here. Combine these terms, and there you go. Negative 3,500p lost 238,000. Okay, now put that in the graphing calculator. Go ahead and put it in here for y equals, so it's ready to go. So let's take a look at the graph. Now, if I just hit graph right now, and I did zoom 6 because that's probably where your window is going to be, you're not going to see anything because it probably costs a lot more than $10 to make all this paint. Let's talk about how to get the windows set up correctly without really doing any work. But if you go down the page, it'll show you how to do a little bit more algebra and get the window settings really perfect. But if you look at what's going on here, and this is from Algebra 1 level, this is your y-intercept. This is your slope. Your y-intercept's at 238,000, your slope's negative. From that point on, you're going downhill. This is as high as it'll ever be, 238,000. So I'm going to go ahead and just say for y max, 250,000. That should give me a little bit of cushion. Should be good to go on that. Okay. Now the price, the x-axis is price. Might have to play with that a little bit. Let's see what this looks like. We should at least see something happening now. Okay. So we are seeing something. But we definitely need to go further out on the x-axis to make this show up. Now that part, you can just play around with this. If you use Desmos, you can just kind of zoom in and out. That makes it pretty easy. If you want to do it correctly, get down the page a little bit. They show you how to find the x-intercept. Well, the x-intercept happens when y is 0. In this case, that's the expense value. We graph this for the y-axis, we graph this for the x-axis. So if that's 0 and you solve for it, the price is $68. Okay, so again, you can kind of guess your way through it. You can do the algebra, it's up to you. But if 68 is as high as the x will ever get before it goes negative, I'm just going to put 70 here, or I'll put 75. It doesn't have to be perfect, just enough to get the graph to show up in the window. And there we go. There's our expense curve. So again, this is in price this way, and this is expense dollars, how much you've spent as a company. This graph, I'll be honest, this graph doesn't convey a lot of information on its own. It's not till you combine it with revenue that it really makes a lot of sense. So don't try to make too much sense out of what this information is telling you. This on its own really doesn't tell you much. This is exactly what we just did in that activity that came before this assignment. But it's more algebra based and less kind of going in, plugging in one at a time and seeing what happens. This is about getting a function that gives you all the values at one time. That's the idea of a function. Instead of having to just plug in a number, see what you get, plug in another number, see what you get, you do a function and you've got every value that it could ever be all at once. All right, that's really the idea of a function. So we know revenue is price times quantity. That idea should be sinking in. If it's not, you need to take a minute and you need to commit that to memory. Revenue is price times quantity. It's how much you sell something for times how many you sell. So it's not a bad idea to remember. It should make sense. So revenue is price times quantity. Now quantity, they gave us the demand curve. That was quantity equals the demand curve. And the last problem, we're using that same, or the last example, we're using that same equation. It's the same idea. You can take Q out and replace it with the demand curve. Again, it's the same thing from the last one, negative 500P plus 30,000. Okay? Same steps. Distribute the P. Tells you all that over here. Okay? They just broke it up, showed P times that, P times that. And then finally simplify it out. P times P is P squared. This one basically you just multiply by P, put at the end. And there you go. That's your revenue in terms of price. This is how much money you will bring in based on what you sell this item for, what price you sell it for, just like the newspaper from the last example. So I'm going to go ahead and put this in the calculator. All right, there it is. Now, notice that my revenue equation uses X, just like the expense equation did, because I'm putting it in my calculator. I don't have a P button for price. It just doesn't do that. So I'm using X. I'm going to go ahead and graph this. Now, I may need to change my window a little bit. The revenue is probably going to go off the screen, and that's okay. Let's just kind of see what happens here. So I'm going to kind of back out and think about what this is going to look like. This is up to 250,000 right now. So if I had to guess, I'd say probably 400,000 for the Y-max should do it. So I'm going to change my window. This is a guessing game. If you get it wrong, you just guess something else. It's not the end of the world. I've seen people spend 15 minutes trying to decide which number to put in. Just put something in there. If it works, great. If it doesn't, try something else. It went off the screen. I'm going to go up to 450,000. Shouldn't be spending too much time on this part. Just try stuff. See if it works. So 450,000. I feel pretty good about that. I think that's going to work out. So again, that expense equation doesn't make much sense on its own. Once you put the revenue in here with it, then it all kind of comes together. So this is how much money your company will bring in based on what selling price you go for. Example 3 takes you how to algebraically find the maximum. I'm just going to tell you now, I'm not going to ask you to do all that. You can find the maximum really easy in Desmos by just clicking on the point. I actually have it preloaded. If you just click on the point right there, it gives you that maximum value. In the calculator, it's a little more to it. You would have done this in Algebra 2. Just to review, second trace, which is right there under calc. You would do 4 for maximum. Now, I don't want to find the maximum of the line, I want to find the maximum of the parabola. So you can hit up and down to switch between curves. Now it says left bound. I know that's the maximum right in there. That's not to the left. I need to go back this way, so I'm on the left side. You just have to get somewhere on the left. Go far enough that you are confident you're to the left of the maximum. That's it. You can come down here if you want, but just as long as you're back here somewhere, you're good to go. Hit enter, switches to right bound. That's the maximum. Get over here somewhere. You can go down here if you want, but don't risk it right at the top. Come a little bit further so you know that you're definitely to the right. All right, feel pretty good about that. Finally, it says guess, because it's actually using something called Newton's method from calculus, but anyway, it is sort of a guess. So that's why you sometimes get these weird values. If you see 29, put a bunch of 9s. You can really call that 30 if you like. From rounding, you could get that anyway. So X is 30. X is price. So $30 selling price brings you the most revenue possible, $450,000. Again, back to Desmos. $30 for your price of one paint. And we're going to make $450,000 in income or revenue. If you keep going through the book examples, they just emphasize what I just told you. Be sure you can give me real information from this. We're not just doing the math here. We're not just doing the Algebra 2. We're applying it to a situation, and we're getting real information out of it. This tells me to sell at $30. If I do that, I will make $450,000 as income. So this is real information. You've got to be able to interpret that from the graph. That's what we're doing. Find the maximum. Make sure you know what the numbers mean. And finally, you put the two things together. Now, I already had this graph together, but it tells you that these are your break-even points. And you break even when your expense and your revenue are the same. If you made enough money to cover your cost, you're breaking even. Your expense and your revenue are the same. That happens in two places, here and here. And this is always the case for this type of problem. There's always two places where you're going to break even. You have a low selling price and a high selling price. You really don't want to operate at either one of those because you're not making any money. It's not profitable. You want to operate over here. Now we're going to get into setting the maximum profit next. And that might be a little bit different than the maximum revenue, but we'll talk about why in the next lesson. But anyway, you need to sell this thing for at least more than 808 and no more than 5892 if you're going to make a profit. Because past anywhere before 808, you're not making enough on what you're selling to make a profit. Your revenue's down here, your expenses are up here. If you sell it for too expensive, you don't have enough customers. You're not having enough people buy it to justify the cost. So it's costing you more than you're making. So that's the idea. Those are the break-even points. In the calculator, you want to do second trace, intersect. I'm sure you did this in Algebra 2 as well. Just enter the first time. And it'll tell you one of these. Now it should be 808, same thing as the other one. That's how much money it would both cost you and what you would make. Now for the other one, second trace, intersect again. But since I've already found this one, I need to scoot over closer to that other intersection point over here. So I'm going to do second right to make it go a little faster, although that's still not going very fast. I guess I'll just hold down on it. My calculator up here is just not very fast, but I'll show you this on Desmos and it's instant. All right? Now the other x is pretty close to it. Enter again, one more time. So 5892. So the same values as what we had on the book. Now if you do it in Desmos, it's way quicker. You just tap those points and it tells you where they cross, and it's a done deal. If you're doing this at home with a computer, Desmos is fine. I'm just trying to show you both ways so that you're able to at least use one of them.